Elementary students solve subtraction problems using a variety of strategies and methods depending on their grade and proficiency level. Today, I will be showing you some of these strategies for solving the following problem, 200 minus 189. So first, we're going to focus on second grade. North Carolina standards for number and operations in Base 10 focus in on getting students to understand place value and using place value understanding along with properties of operations. Specifically, North Carolina Standard for Second Grade, NBT.7, states that students should be able to add and subtract within 1,000, relating the strategy to a written method using the following: either concrete models or drawings, strategies based on place value, properties of operations, or relationship between addition and subtraction. This standard calls for students to extend their understanding of addition and subtraction to add and subtract two 3-digit numbers, like we have on the screen. They use concrete materials, models, drawings, place value strategies, and properties of operations to add or subtract within 1,000. The standard algorithm of carrying or borrowing is neither an expectation nor a focus in second grade. Second grade students use base 10 blocks or snap cubes to solve subtraction problems. For the purpose of this demonstration, I will be using base 10 blocks. And having students use hands-on manipulatives is often most helpful for children at this age. So first, the student would examine the problem that we have on the screen, 200 minus 189. They first would model 200 by using two 100s blocks. Next, they would look at the following number, 189. They know that 100 can equal one 100 block, and 89 can be represented by 8 10 blocks and 9 1s cubes. As children are doing this in person, they may be using one-to-one correspondence to move the manipulatives into the placement that they would like. So here they have 200 again, and 100, and 1, 2, 3, 4, 5, 6, 7, 8 tens blocks, and 9 1s cubes. Right away, a student may be able to notice that 200 and 100 both have at least 100 in them, and may immediately be able to notice that they could have the ability to take one away. Now what's left for 200? 200 would now become 100, and 189 would now become just 89, because the student was able to subtract 100 from each. So, they may have trouble seeing 100 represented in a 100s block. So, they may change this 100 into 10 10 blocks instead. In doing so, the student would be able to compare the 10 tens blocks and 8 tens blocks over here. And like before, they may use a strategy of marking out for subtracting 100 minus 80, still not necessarily touching the 1s cubes just yet. So they may mark out 1, 2, 3, 4, 5, 6, 7, 8 tens blocks over here, and they know that they have 8 10 blocks over here. In doing so, they would be able to see that 8 10 blocks over here could be taken away from the same 8 that they had to represent their 80 over here. And once the student does that, they now see that their problem has been reduced to 20 minus 9, still using 2 tens blocks over here and 9 ones cubes over here. This still may be a bit hard for students to see, so they may choose to take away one of the tens blocks and represent it with 10 ones cubes. In doing so, the student could continue using on the strategy that they have been using of crossing out. So they're taking 9 away from 20. They know that they have 9 ones cubes here, 1 tens blocks, and 10 ones cubes. Knowing so, with using 10 as a benchmark, students may be able to see that 9 minus 10 right away is just 1. They would be able to see that all 9 of these cubes could be taken away from the 10 that they have here, meaning the student would just be left with 1 tens block and 1 1, because all ones blocks over here have been subtracted from each other. Now, the student would be able to see that their solution should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Students may also use one-to-one correspondence when counting their final solution to make sure that they get the correct answer. Moving on to third grade, the North Carolina third grade standard NC3.MB2.2 expects students to use place value to add and subtract. Respectively, students should be able to add and subtract numbers up to and including 1,000. They should be using estimation strategies to assess reasonableness of answers, model and explain how the relationship between addition and subtraction can be applied to solve addition and subtraction between problems, and use expanded form to decompose numbers and then find sums and differences. In this standard, students build on work in previous grades regarding strategies based on place value, properties of operations, and relating addition to subtraction. Students should be able to use the expanded form of a number to calculate sums and differences. Students explain their thinking and show their work and verify that their answer is reasonable. So as a third grader, looking at 200 minus 189, I would want to use a number line, and I will show you how to do so on the screen. Most students would see that 200 minus 189 might not be the easiest number to quickly do in your head. So, using a number line in compensation, they may change 189 to 190. In doing so, they added just 1 to 189. Starting at the number line and starting at 200, they could easily and quickly see a jump from 200 to 190 would be 10. And since we are doing subtraction and they started at 200, we're taking 10 away to get to 190, which would make this minus 10. But now looking back and referring to our problem, we see that it's 200 minus 189, not 200 minus 190. Because we added 1 earlier, we will now need to bounce back just 1 from our 190, which would get us to 189, which is represented in our problem. A student now may see that 10 minus a 1 and be able to think of it as a sense of addition. Because we had a jump of 10 here and bounced back just 1 here, they would be able to add 10 plus 1, which would give them the correct solution of 11. Students would be able to communicate this by using 10 as a benchmark and knowing that 200 minus 10 would give them 190, take away 1 more to get us back to our original number in our problem of 189, adding the 10 and the 1 to get their solution of 11. Moving on to fourth grade. Fourth grade is the first time that students are expected to use a traditional algorithm. The standard for fourth grade, MBT.4, puts focus on the use of place value understanding and properties of operations to perform multi-digit arithmetic. Students are expected to add and subtract multi-digit whole numbers up to and including 100,000 using the standard algorithm with place value understanding. This is the first grade level in which students are expected to be proficient at using the standard algorithm to add or subtract. However, other previous learning strategies are still appropriate for students to use. As a fourth grader, looking at this problem, 200 minus 189, it may be easier to view the problem vertically instead of horizontal. So you have 200, and I'm spacing it out in a sense of place value. We have our hundreds here, then our tens, and then our ones. And at this time, students should be able to understand the value of place value. Looking at this problem, students should be able to recognize that you cannot take away 9 from 0 or 8 from 0. First, we know that we can change the 0 to a 10 by taking one of our tens away from 200, which would make this 1, which would then change our 0 to 10 tens because we took away 100 from our 200. But that still does not help us out in this column. We still cannot take away 9 from 0. We would then borrow one of our tens from our 10 tens in this place, make this 10 of our tens, 9 tens, and bring one of our tens over to our 0, making this 10 ones because we are in the ones place value column. Students may see now that 9 minus 10 is 1. We can now take away 8 from 9, leaving us with 1. In this column, we're in our tens, so this really represents 1 tens and 1 1. Moving on to our 100s place, they can now see that 1 minus 1 just leaves us with 0, which would give them the correct solution of 11. So, students are introduced to subtraction in kindergarten, and while students should be exposed to a multitude of different strategies and methods to complete an equation, there are certain strategies that may be more appropriate in each grade level. In order to be proficient in subtraction, children must first have a sense of place value and quantities. In second grade, students are expected to be able to add and subtract through 1,000 using knowledge of place value. The same expectation is withheld in third grade, but students are expected to use strategies of estimation and model and explain how the relationship between addition and subtraction can be applied to solve addition and subtraction problems. In fourth grade, students continue to use place value in describing and justifying the processes they use to add and subtract. Students are expected to explain their thinking to show their understanding of the algorithm. Again, fourth grade is the first grade in which students are expected to use algorithm. The standard algorithm of carrying or bothering is neither an expectation nor a focus up until fourth grade. Students develop and use strategies for addition and subtraction in grades K through 3.